Hello there, my name is Malte Leander and I am one of the recipients of the 2021 Concordia Undergraduate Studies Research Award for my project titled Developing and Designing Original Electronic Instruments and Sound Generators. I am currently a fourth-year student in the program of Electroacoustics, part of the music department, and had for this project in mind to develop my own original electronic instruments that could be used in a variety of contexts, used in live performance, in the music studio, or exhibited as a sound installation or sculpture in an art gallery. Having worked with sound in a lot of other fields and areas, I had never created my own devices to make sound. I rely on synthesizers or software to generate the material that I need, so the thought of designing and creating something from scratch was a bit daunting, yet a very exciting task. This was an incredible opportunity for me to dive into an area that was completely unknown to me, getting deep into the world of electronics to understand the flow of electricity, and by doing so, learning how to alter the sound coming out of an electrical device. In doing that, I was starting off my practice by learning about something called circuit bending, which is a technique often implemented on electronic toys, where the circuit is modified in different ways to generate interesting results in the sound that is coming out of them. So I popped open a lot of toys in my learning by doing approach, together with lots of readings on the matter, familiarizing myself with the terminology and techniques and making sure that the circuit doesn't fry, meaning that it short circuits and is after that completely useless, which is something that did happen more times than I want to admit. But slowly I got the hang of it and learned different implementations that I could add to change the sound from a pleasant voice to something different. The second half of this project was also to design the casing, the outer shell that would contain the electronic circuit. With that part, I had great assistance and help from the digital fabrication lab at Concordia, where I worked closely together with Jules Beauchamps Desbiens and Gabriel Scott-Seguin on the process of 3D printing and laser cutting some of the pieces necessary for the assembly of the toys. This part took a lot of trial and error, and we had prototype after prototype with millimeter changes on distances, diameter, sizes of holes, button lengths, just to mention a few. It was a tedious process that required a lot of work to strike a balance between the aesthetic that we were after, yet still maintaining the functionality that was necessary. Some of the buttons were 3D scanned, rendering them into 3D objects that were then able to be printed out. This resulted in a collection of different objects that I'd chosen to be mounted on switches, buttons, and knobs that were all filling different functions in shaping the sounds that the toys could output. To have some sort of linkage to where the devices were actually deriving from the children's toys, I chose this aesthetic for my instruments to be kind of playful or be in the same domain as from their original sources, whereas the sound that they're outputting is quite different from how they sounded originally. After the first toy, the remaining went a little easier and faster as they had a similar construction flow from idea to assembly. The result became a selection of one-of-a-kind original electronic instruments deriving from old children's toys, but now with a completely different sound and new looks. So at the time of recording this video, the fourth and last of the toys in this series is under construction, and I will therefore only be able to demonstrate 3 of them. So before leaving you today, I figured I would show you some clips of how they work and how they sound. So thanks for taking the time to listen to my presentation and for the customer award this year that yielded this project. Thanks a lot.